Hey, I'm glad you have made it to this part 2 video on solving polynomial equations. So welcome back. Now on the screen you see here we have a cubic equation. So this is the third-degree equation right here. So the coefficients here are 1 for A, 4 for -4 for B, and we have 1 for C, and the constant value is 6. So the coefficient that is leading, the most important for us, is 1, and the constant term is 6. So this is the case where we have leading coefficient equal to 1. So pay attention to that. So we do find, in that case, only factors of the coefficient of a constant value, 6. So this is what we want to find out. So simply by inspection, we know that the divisors or factors of 6 are plus or minus 1. We have plus or minus 2. Same for 3 and plus or minus -6. So the next step is to say I have 2, 4, 6, 8 possibilities. And if I'm looking for a solution to this, my solution must be contained in this 8 possibilities. So one of the numbers will make it happen for us. So all you have to do is just by inspection find which factor, -1 or 1, -2 or 2, -3 or 3, -6 or +6 will make the value of this coefficient of this polynomial equal to 0. So x is equal to -1 actually makes the value of this polynomial equal to 0. So recall the factor theorem. If -1 makes it 0, so x minus -1 is a factor. So x plus 1 is a factor. Therefore, we are so excited at this point and we say, now I can divide my given equation by x plus 1 and I anticipate no remainder. Boom. So we divide using long division. We divide x plus x cubed minus 4x squared plus x plus 6 divided by that, our factor, and this is our result. So we have accomplished very important step. We have found the first root of that equation, which is -1, right here. And also we have lowered the degree of the cubic equation, because now we can express this entire cubic equation in factored form right here. You see that now I can solve quadratic equation. When I solve a quadratic equation, I remembered how to do it from the previous video. I can use factoring or quadratic formula. So I anticipate up to 3 roots to this equation. So cubic equation, maximum number of roots that you will have is 3. You have to have 1 real root. Why? Because cubic function has to have at least 1 x-intercept. You know that from previous videos. If you don't, go back and review. So the focus now is to find the solution to quadratic equation. So let's do it. All right, we have this factored form listed on the screen, and the next step is to find solution to quadratic equation. If you choose to do it by factoring, so the product is 6, and why the product is 6? Because coefficient in front of x squared is 1, so 1 times 6 is equal to 6. Middle term -5, so that's the sum. So you're looking for two numbers, multiply into 6, and two numbers, the same two numbers, add up to -5. So the two numbers are -2 and -3. So the next step is to express the middle term in terms of the two numbers that we just found. So this is why you have -5x replaced with -2x minus 3x. You have four terms in this equation right now. You can group them in two groups of two. So if you think of this as the first group, the common factor is x right here. So that goes out. For these two terms right here, the common factor is -3. So you take it out. So this is why that line right here has this format. X common factor in brackets x minus 2 minus 3 in bracket x minus 2. And look at that. X minus 2 and x minus 2, same factor. So this becomes a common factor. Take it out. X minus 2 goes out. X minus 3 goes in. And you further solve that. And you get so excited because the solution here now is -2 is equal to x minus 2 is equal to 0, so that gives you 2, that gives you 3, and the third root is -1. So this is the set of roots for that equation. Check, check, check. Cubic equations, 3 real solutions, beautiful. So the next example will be working with a quartic 4th-degree polynomial. So let's begin. Alrighty, so we have in this example two things. The first coefficient, the leading coefficient value is different than 1, so this is 6. The constant is -1, so this is why you have e is equal to -1. So please note that we used letters from Latin alphabet. So the first coefficient is a, the next is b, c, d, e, and so on. So now, in case a is different than 1, we have also expanding our possibility. Just think for a second. If I were to divide both sides by 6, right, my constant term would be -1/6, and my leading coefficient would become 1. So this is why that step would imply that the factors that you're looking for are factors of -1/6. So we have factors of -1 to consider. We have also factors of -1/6 to consider. So the list now is -1 and +1, right? And -1/2 and -1/3 and +1/2, +1/3. Why? Because 1/6, fraction 1/6 is equal to 1/2 times 1/3. So this is why those are the possibilities. Excellent. So the process will repeat. What do I do with this? So I have my possible factors. Now I have to find which of those factors would make it 0. So by inspection, you just do find what value of x would make that polynomial equal to 0, and 1 that works. If 1 works, 1, because it comes from that set, makes it 0, therefore x minus 1 is a factor, which means that I can divide this quartic by x minus 1, and I should not get a remainder, because this is a factor. So I have found one root, which is equal to 1. Now, when you divide quartic by linear, you get cubic equation as your solution right here, and you will repeat the process. Okay, so now we have reduced this quartic equation into a product of x minus 1 times the trinomial x 6x cubed plus minus 7x squared plus 1 is equal, and this is equal to 0. So the next step obviously will be to work with the cubic. So let's work with the cubic polynomial. By just observing that the cubic polynomial also has non-1 leading coefficient and the constant that is 1, so the factors of constant are -1 and 1, and we have the same factors of 1 over 6. So this is why you continue working with the same group of factors, and you're finding by inspection which number, either plus or minus 1, or either plus or minus 1 over 2, or plus or minus 1 over 3 makes it 0. And fortunately, in this case, 1 makes that cubic polynomial equal 0 when x is equal to 1. So now we know that x is equal to 1 is a double root. It works twice for us. So the story repeats. If I have found this monomial, so the factor now is x minus 1, and I can divide a cubic by x minus 1 again. When you divide, you'll get a product, x minus 1 times 6x squared minus x minus 1. So the factors now are, the first one is x minus 1, the second also is x minus 1, and now you have quadratic equation. Isn't that beautiful? Quadratic equation now, you know what to do. This is the moment that you get very, very excited. So let's do solve quadratic equation. And we can use quadratic formula, plug in your quadratic formula, knowing what A is, knowing what B value is, knowing what C value is, and it works nicely. And now I see x3 is equal to 1 over 2 and x4 is equal to -1 over 3. Wait a minute, so where is x1 and x2? They are the same roots, equal roots. So they already have been found. So this is the final factored form to that equation. X minus 1 squared as double root times 2x minus 1 times 3x plus 1. So what we have found here, that this quartic equation had 4 roots. So the degree 4 is equal to 4 real roots. Does it always work like that? No. I can have no real roots if my degree is 4 or 2 or 6. So even degree polynomials may have no roots, no solutions at all. If you have no roots in real numbers, then you anticipate to see roots in complex numbers. So that's one thing. If you have a complex roots, they always come in pair. So if I have 2 real roots for quartic equation, I have to have 2 complex roots, so that makes it 4. The total sum is 4. If I have 1 real solutions to quartic equation, so in that case, this is the same root repeated 4 times. For example, this simply means that I may have x to the power of 4 minus 16 is equal to 0. Right? So this will be, that was supposed to be 0. So this is why you would have 4 roots here, right? And no complex roots. I cannot have 3 real roots and 1 complex root. This is impossible in the set of real numbers. Okay, so this is not possible. Alrighty, so now you do know how to solve cubic and quartic equations, and the solutions only make sense and it is possible if roots are either rational numbers or integers. In case the real roots are decimal numbers, this method would not work. You would have to use a technology, namely graphing calculators, or do it by approximation method. But roots, when they are expected to be in real as integers and rational numbers, this is the method that it's called by factoring, and you have learned just this method right now when you need to solve cubic or quartic equations. Thank you very much for your attention. I hope you have enjoyed watching this video. If you have any questions, any comments, please post them right below this video. Thank you. Bye for now.